This video is on triangle theorems. We're going to be talking about all the different types of theorems that you could see in triangles. So I'm going to turn the page. The first thing on triangle theorems is the triangle inequality theorem. The triangle inequality theorem states that the sum of the two smaller legs of a triangle is greater than the larger leg. So in order for it to form a triangle, your two smaller legs have to add to be bigger than the third leg. So 4 plus 5 is 9, which is bigger than the 7. So that means that this will form a triangle because these two legs, as they start closing on the triangle, they will actually close before they hit the third side. However, if you have your two smaller sides, like 4 plus 2 is 6, is not bigger than 7, these will not close and will not form a triangle. That also states that they cannot be, it says they have to be greater than, cannot be equal to, it's got to be greater than. So if I had 4 and 3, 4 plus 3 is 7. So as these close, 4 and 3, as they close, they'll close and hit together on the third side. So it'll form another line, not a triangle. So the two smaller sides have to add to be bigger than the third side. So to look at some examples, we'll look to see if these two smaller sides, whatever the two smaller sides are, will add to be bigger than the third side. So we look at 1 plus 1, or your two smaller sides. Is that bigger than 6? 1 plus 1 is 2, so it's not bigger than 6. Therefore, this is not a triangle. If we look at example B, the numbers are not actually in order. We want the two smaller sides first. So it's 7 and 9. 7 plus 9 is supposed to be greater than 21. 7 plus 9 is 16, so this is not greater than 21. Therefore, this is not a triangle because this is not true. So this is a no, and this is a no because this is not true. Example C. Again, your numbers are not in order. We want the two smaller sides first. So we talk about 6 plus 8. Is that bigger than 10? 6 plus 8 is 14, which is bigger than 10, so this is a yes. That means that this is a triangle. The next example, example D, we have the two smaller sides are in order, so it goes 3 plus 8. Question is 3 plus 8 bigger than 11? 3 plus 8 is equal to 11, so it's not bigger than, so this is a no still. This is not a triangle. Because what will happen is that these two sides, as they start closing, they'll end up touching on the base. They'll close on the base and they won't actually form a triangle. They'll just form a line. So you have to determine if it is a triangle. Once you determine that it is a triangle, you can go on and actually classify them. We're going to start with the Pythagorean theorem. This is probably a theorem that you have heard in the past. The Pythagorean theorem states that if a triangle is a right triangle, then the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. Now, what this really states, so it says the sum of the squares of the legs. That's really leg squared plus leg squared is equal to the square of the length of the hypotenuse. So that's equal to the hypotenuse squared. Now you have to remember what part of the right triangle you're dealing with. The hypotenuse is actually always opposite the right angle. The hypotenuse is always opposite the right angle. So if triangle ABC is a right triangle, and we can see that it is because it has this box in here stating that this is 90 degrees. So if this is a right triangle, we have our hypotenuse. Here's our right angle. Opposite of the right angle is our hypotenuse. So your hypotenuse is C. Then we can state that A squared plus B squared equals C squared. Because A is your length of your leg, B is the length of your leg, and C is the length of your hypotenuse. So we have A squared plus B squared is equal to C squared. An example of this is a word problem. It says Jamal leans a 12-foot ladder along this 12-foot long ladder along the side of the house. The base of the ladder is 4 feet from the house. To the nearest tenth of a foot, how high on the house does the ladder reach? So since this is a word problem, the best thing to do is to draw a diagram. So we know we have a 12-foot ladder leaning against the side of the house. So we know the house is going to go vertical. And we have a ladder leaning against it. So the ladder can be leaning against it like this. But we also know that these aren't floating in air, so it's going to be on the ground. And we know that a house and the ground should be perpendicular to each other. We should have a right angle. Vertical and horizontal should always be perpendicular. So now we fill in the information. It says that the 12-foot long ladder. Well, this was your ladder, so this is what we put as 12. Then it says the base of the ladder, which is right here, this is the base of your ladder, is 4 feet from the house. This is 4 feet away from the house, so we put the 4 here. It says to the nearest tenth of a foot, how high on the house does the ladder reach? So you're asking for this length right here. So now we have a right triangle, we can use Pythagorean theorem. For Pythagorean theorem, we're using a squared, so the leg squared. First leg is your x. We're going to have x squared plus your other leg is 4. We're squaring it, is equal to your hypotenuse squared, so 12 squared. So we'll have x squared plus 16 is equal to 144. We subtract the 16, we get x squared equals 128. We need to solve for x, so we square root to get our x value. And it's to the nearest tenth, so we say that x is approximately 11 3/10 feet on the wall. Now this answer actually makes a lot of sense. We know that the ladder is only 12 feet long, so we know that the ladder can't reach higher than 12 feet. We also know that for it to reach the 12 feet, the ladder has to be going straight up and down, which if the ladder's going up and down, it'll fall over. That's why it has to lean against the wall. So it is leaning against the wall 4 feet away, but it's still making enough angle to be able to get up a little over 11 feet onto the wall. So again, once we determine that if it is a triangle, this was specifically for right triangles, that a squared plus b squared equals c squared. However, the Pythagorean triples are actually, it states a generalization of the Pythagorean theorem, which can classify not only right triangles, but obtuse and acute triangles as well. So what we want to do is we're going to use the Pythagorean theorem, but we're going to be able to classify them as right, acute, or obtuse. This has to happen if it is a triangle. So if it is a triangle. So you have to make sure that it does in fact form a triangle before you determine what type of triangle it is. If it's not a triangle, it can't be one of these types of triangles then, because it's not a triangle. So you always have to determine if it is a triangle first. So we're going to use the generalization of the Pythagorean theorem to determine what type of triangle it is by angle, right, obtuse, or acute. Now, if a squared plus b squared is equal to c squared, so that's what we're looking at, that equals to c squared. If it equals to c squared, then it will be a right triangle. If you do the same Pythagorean theorem, but if c squared is bigger than your a squared plus b squared, it's an obtuse triangle. And therefore, if c squared is smaller than everything else, then it is an acute triangle. So again, you have to determine if it is a triangle first by doing A plus B is bigger than C, then if it is, then you can use your Pythagorean theorem. But don't square them until you determine if it is a triangle. So we're going to do examples over here. We're going to classify the triangles, and it is going to be by angle. By angle. So the first thing we do is determine, is it a triangle? So we have the side lengths of 12.5, 30, and 32.5. So we add the two smaller sides first. So we look to see, is it a triangle? So triangle. 12.5 plus 30 is 42.5, which is bigger than 32.5. So yes, this is a triangle. That means that we can classify it. So we take our two smaller sides, A, B, and then our third side will be C. We focus on 12.5 squared plus 30 squared, and we figure out what it is to 32.5 squared. So 12.5 squared plus 30 squared is 1,056.25 or 25 hundredths. And 32.5 squared is equal to 1,056 and 25 hundredths. So we ask ourselves, how is the C value, C squared, related to the other everything else? The C squared is actually equal to everything else, therefore this is a right triangle. In this next example, we again have to determine if it is a triangle or not. So I'm going to put a triangle over here. Our two smaller sides are 4 and 9. 4 plus 9 is 13, which is bigger than 12, so yes, this is a triangle. Now we can classify it. Now we use the variation of the Pythagorean theorem. A is 4, so we're going to do 4 squared plus B is 9, so 9 squared is what to our C is 12, and we're going to square that. So 4 squared plus 9 squared is equal to 97. So 97 to 144. That's what we're looking at. Focus on the 144. Is the 144 bigger, smaller, or equal to everything else? The 144 is bigger, so therefore it's an obtuse triangle. And again, if we had said that this was not a triangle, we would not have done anything else on the problem. We would say it's not a triangle and be done.